We have p and q are distinct primes. M and n are positive integers where m is bigger than n. Find the greatest common divisor of p to the m, q to the n, and p to the n, q to the m. And likewise, the least common multiple of those same two integers, p to the m times q to the n, and p to the n times q to the m. The greatest common divisor, we need to find, we've got the prime factorizations here. So I need to find the least power for both primes. So we have p to some power and q to some power. And I need to take the least exponent. So m is bigger than n. So the least power of p is the p to the n. Likewise, the least exponent for q is the q to the n term. And so that'll be the GCD. LCM, I need to take the largest exponent. And so for this one, it would be p to the m would be the biggest exponent. And likewise, on q, the largest power of q is q to the m. And so we have q to the m. For the second one, there's an alternate way of doing it because it's only two numbers. So this other way only works because it's two numbers. But we could take the product of the two numbers. So p to the m, q to the n, times p to the n, q to the m. And then divide by the GCD, which is p to the n, q to the n. And we see that p to the n, q to the n cancels, leaving us p to the m and q to the m as the LCM. So this little trick in green works because I have two numbers that I'm finding the LCM of. This doesn't work for three numbers, but it does work for two numbers. But it always works that to find the LCM, you list out the prime factorization and then take the highest powers of all the primes.